Hello students, this is Mr. Yao. In this lesson, we are going to learn to understand the line of best fit better. Last time we have learned how to actually draw the line best fit by hand. So let's look into this lesson and see what we're going to do today. First, prior knowledge, given a general linear equation in the form of y equals mx plus b, what does m and b mean? M, of course, is the slope, and b is the y-intercept. In today's lesson, our linear equation is gonna look slightly different. In the last lesson, we have generated line of best fit by hand, and we may have noticed that they were not the most precise representation of the data. In this lesson, we will use our calculators to help us find or write the linear equation that best represents the data, also known as the line of best fit or linear regression. Linear, well, because we're generating a straight line. Regression is kind of the meaning of trying to narrow down the data so that we can actually have a trend, a clear trend that we can follow. So let's actually get our calculator ready and see how to do it with a calculator. So let me turn on my calculator. Here it is. I'm gonna need to make it smaller so that you can see the rest of the stuff. So let's get going. Step 1. On your notes, step 1 only says reset the calculator, but there is something that I forgot, so we are gonna need to actually add on that. So right next to your step 1, please add on these words that are in red. After you reset your calculator, so let me do that first. I'm gonna click second and then plus 712. And there we go, our calculator is clear. And then afterwards, you're gonna need to click mode. And as right now, you don't see these words, stat diagnostic. You're gonna need to use the down arrow, keep moving down. Mode is basically your setting in your calculator. So I'm gonna keep moving down. Right here, I see stat diagnostics. And right now it is off. So I need to move it over to on so that the on is highlighted. Then I press enter. Now you can see it's not off anymore, on is being highlighted. That means I have turned on the diagnostics. What this does is basically allowing you to get more information about your data set, which is what we are gonna need to do today. So now moving on, I can just click enter. I can just click clear to get out of that. Next step. Step 2. The first few steps are actually quite similar to what we have learned before about how to find a standard deviation with our calculators. So step 2 is press stat, then choose edit. Press stat right here, then we're going to choose edit, which is the first one. And now you see the L1, L2, L3. That's the screen we have seen before. You should see a screen that allows you to enter the data into a list. But instead of just entering one list of data, this time, step 3, we are going to type the data into L1 and L2. So L1 is going to be our X, and L2 is going to be our Y. So I'm going to start typing into L1. So 1, 2, 3, 5, 6, 7, 7.5, and then 8, and then 8.5, and then 10. These are all the numbers that I need in my L1. Now let's actually have a look at L2. Right here, I'm going to need to use my cursor to move to the right so that I can type in L2. 20, 40, next is 40 again. Then we have 50, 60, 60 again, 80, 70, 75, and last one, 80. And we do need to make sure everything is actually corresponding. It is with 10, 75 is with 8.5. That's actually very important. Make sure all the values in L2 are corresponding with all the values in L1. Moving on, we're going to do something similar again as a standard deviation. So step 4, after you finish typing all the data, press stat, but this time we're going to choose calc. So I'm going to click stat again, but this time I'm going to move the cursor over so that I can choose calc. Last time when we did a standard deviation, we were actually using the first one where it says 1 var stats. This lesson, of course, we're not going to use that. Instead, step 5, we're going to choose 4 lin reg ax plus b. Right here, lin reg ax plus b, which stands for linear regression, and our equation is going to have the form of ax plus B. That's exactly what we need. So I'm going to click 4. Now you see this screen. The first one is actually asking you to make sure that your X list is actually going to be the first list, is going to be L1. Of course, if you need to change the names, let's say it's going to be L3 or L4, you're going to need to click second and then choose 3, because on top of 3 is L3. And as of right now, our X is actually L1, so I just need to click enter. And then our Y list is actually L2, so I just click enter again. And for these, we don't need to worry about them, so I'm going to keep clicking enter until, as of right now, you see the word calculate being highlighted. So I click enter again. There we go. Now we have our lin reg. So I can actually start writing down these things, these information. A is, I'm going to round them to 2 decimal places. So 6.398 rounds to 40. My B is 20.390, so 20.39. And then I don't need my R square as of right now. For this year, we're just gonna need our R. R is 0.96. But we're trying to find a linear equation. The linear equation is going to be AX plus B in this form, AX plus B. So A is 6.40, so 6.40x plus 20.39. If you recall, this data list is actually what we used in the previous lesson, where we were trying to find the line of best fit by hand. When we did it by hand, the numbers we got were 20 over 3x plus 20. As you can see, the numbers are quite close, but of course, the calculator answers is going to be more precise. Okay, there's the last bit of notes. We're going to move on, and I'll come back to it when we get to examples. So, moving on, let's actually have a look at the screen a little bit more. The screen that you should be able to see is right here. The linear equation is in the form of y equals ax plus b. A, of course, is the slope of the line. B is the y-intercept. As for R is the correlation coefficient. We haven't learned what correlation means in the last lesson. It's basically a relationship between two different variables. But knowing there is a relationship, we also need to know how strong or how weak they are. So here it is, correlation coefficient, letter R. It is a number that measures the strength of association between two variables. The values of R range from -1 to 1. The strength is identified as strong correlation, moderate correlation, weak correlation, and no correlation. Well, it's basically there are 4 different levels. One kind of represents the 100% of a very strong correlation. So that is 100% of a positive correlation. As for -1, is actually going to be 100% of a negative correlation. So here's how everything is going to be spread out. In fact, no correlation is not just a 0. It's actually a little range from -0.09 to +0.09. And then, as you can see, we have the weak, the moderate, the strong starts from the 0.8 to 1, and the -1 to -0.8. Everything is kind of symmetric to the middle. On the left is going to be negative, and on the right is going to be positive. That's kind of how we describe the correlation. Okay, before we move on to the next the examples, let's actually look at the last part after the steps. Before, when we actually did the standard deviation, and whenever we needed to clear the data, here's what you actually did. You were simply getting to the data, or some of you would just type in the new data. So you would actually go to stat. Let's see, stat, and then click edit. If you want to type in the new data, you can just replace these, or some of you are just clicking on delete, and keep on clicking delete to actually get rid of everything. However, there is a faster way to do it. Here it is. You can clear the list by using the arrow up to highlight L1 or L2. So for example, I can move it up. Now you see L1 is highlighted, and I can just click clear and then enter. Now you can see L1 is completely gone. I can now move it to L2 up so that L2 is highlighted. On the bottom, you can see it kind of shows you everything that's in L2. I'm going to hit clear again and press enter. Now you can see L2 is gone as well. So that's the little bit. It's going to make clearing the list faster. Now let's actually move to some examples. example 1. Let's type in the data. The data that we have, since we're already in the list, I'm just going to start typing. So I'm going to need to type in my x under L1. So I have 0, and then 1, 2, 3, 3, 4, 6, 7, 8, and 8. Moving on to L2. I have 60, 70, 77, 75, 84, 90, 88, 98, 100, and last one, 90. There we go. All the numbers are corresponding, so I just need to go through the process, click Stat, go to Calc, and I'm going to choose number 4. X is L1, Y is L2, so keep on clicking Enter until Calculate is being highlighted. I click Enter again. Now I have all the information that I need. For my A, I'm going to actually round all of these answers to 2 decimal places. So for my A is going to be 3.98. For my B, it is going to be 66.5. Would you look at that? It's actually, we don't need to round it. And our R is going to be 0.91. So our equation AX plus B is going to be 3.98x plus 66.5. As for the correlation, well, our R is 0.91. It is quite close to 1. It's in that range of 0.8 to 1. So it is going to be a strong positive correlation. Now let's move on to example 2. I'm going to move my calculator to the left so we can see clearly. I'm going to go to Stat and click Edit again. You don't have to delete, but just to make sure you're not missing any numbers. Or for example, a data set may have less numbers, you may mess up. I would actually still suggest you to clear everything. So click Clear, Enter, and move on to L2, Clear, Enter. Now let's start typing in the new data. I'm going to have 0, and then 9, 18, 27, 34, 39, 41, 43, 49, and 52. 10 data. Moving on to L2. I have 6, 8.6, 10, 13.6, 15, 14 point, oh, not a comma. I need to go back and actually delete that. And so it's actually going to be a dot, 14.8, and then 16.1, 17.2, 19.8, and last one, 18.5. There we go. It is corresponding with 52. I have everything. So Stat, Calc, number 4. Keep clicking on Enter until the very last step. I have all my information that I need. My A in this question is going to be 0.25. My B in this question is going to be 6.04. So my equation is 0.25x plus 6.04. My R is going to be 0.99. That's even bigger than the previous example. So of course, it's going to be a strong positive correlation. That's example 2. Moving on to example 3. Before we do that, well, the reason we're learning these stats and trying to find a line best fit is actually to predict or estimate some values. Because we only have a certain amount of data to generate this line of best fit. But if we want to go further, bigger numbers, then we're going to use the line of best fit to actually make a prediction. So let's have a look at example 3. First, of course, we're still going to need to find all the things that we need for the line of best fit. So let me go through that process again. Start, edit, go up to L2, clear, enter. Go to L1, going up, clear, enter. There we go. Now I can type in the new data set. Here's the thing. As you may notice, in the last line, I have 55 and a question mark. There is no way you can type in a question mark. And these pairs of data points would actually present points on the plane. That's why for the last one, we don't even know what that point is. That's why we're not going to type in that last row into the calculator. So now let's get going to type in the numbers for our x and y. So first, 5 is the first one. Then I have 10, 20, 25, 35, and 40. 6 numbers. Moving on to L2. 9, 17, 22, 30, 38, and 44. These are all the numbers. Go through the process, stat, and then calc, choose number 4, keep clicking enter, enter all the way down, and now I can get all the information that I need. For this question, my A is going to be 0.95. My B is going to be 5.19. And my R is going to be 0.99. So that means I have a very strong correlation again, a strong positive correlation. But before we get to that, let's actually write down the equation. Y equals 0.95x plus 5.19, and is a strong positive correlation. Lastly, the question is also asking you to predict the missing value. The missing value is when x is 55. So we're going to use this line of best fit because that's the whole reason we're trying to find this line of best fit. We're trying to know how much does the data fit on this line and how much can we use this line. So of course, now we're going to use this line. All we need to do is take this number 55, plug it into the equation for x. So y equals 0.95x, well, not x, times x, which is 55, plus 5.19. Put that into your calculator. You should get an answer of 57.44. So that is our prediction. When x is 55, our answer is going to be 57.44. And that is example 3. Next, for example 4, I would actually suggest you to try it out by yourself. So you can pause here, try the question by yourself, and then you can come back to check the answers. Because it is the same process as of what we have learned in the last lesson and this lesson. So, pause right here. Hopefully now that you have tried this question, here is example 4. And these are the answers. Check the answers. If you have any questions, please ask. But that is everything for this lesson. Thank you.